Hello guys, good morning. Welcome you all on Unacademy, India's largest learning platform. So we are going to start this MBBS First Prof series. Now, first of all, a little bit of introduction, then we'll start the topic. Today we are going to study about the body fluids. First of all, a little bit of introduction of myself. Myself, Dr. Nidhi, I am your physiology educator at Unacademy. This is our Telegram page. Let's crack NEET PG. You all can follow us out there so that you'll get link and updates of every classes. This is my page on Unacademy, that is unacademy.com/@kgmc. You can follow us out there so that you will get link of my every upcoming courses. This is the code Dr. Nidhi. If you want to join any paid course, you can use this referral code to get additional 10% off. I've taken many plus classes, many special classes. So anytime you can join and revise your topic. This is the NEET PG Friday test calendar for the April 2022 last week. That is from 18th April to 24th April. So these are the upcoming tests. You can join by free of cost. These tests are, you have to bus use the code, that is the Dr. Nidhi. By using this code, you will unlock all the free tests. Do give the test because that is helping you to analyze your preparation at any point of time. So moving further, we have two type of subscription: plus subscription and iconic subscription. First, coming to the benefit of all these plus subscription. When you take plus subscription, you are able to access both the live and recorded session. If by chance you miss any session, you can see the recorded version also. You have an opportunity to learn from India's top educator for the medical examination. We always conduct this live test and live quizzes. From that, you can analyze your preparation at any point of time. You have a flexibility. You can study on the device of your choice. You always carry your phone with yourself, so you can access your classes from your phone only if you are anywhere. So we have a question bank which consists of this high yield clinical based question and with explanation. So this is going to be very beneficial for all of you. Now coming to the iconic subscription, where you get access of India's two best platform, that is Unacademy and the Prep Ladder. So you are going to get all the plus benefit. Like I said, live classes, recorded classes, question bank, live test, live quizzes. Along with that, you access for the Prep Ladder. Coming to the Prep Ladder, you can access the clinical and integrated essential of Prep Ladder, video lecture from the Dream Team, Question Bank 3.0 with active guidance, rapid revision and snapshot, and you will also be provided with the Treasure 2021 Dream Notes. So if you want to access the Prep Ladder also, go for the iconic subscription, everybody. Moving further, we have started this Unacademy Lite for the NEET PG. If you are looking for all the test series only, you can join this Unacademy Lite for NEET PG. In this, you can access the subject-wise test, system-wise test, full-length mock test paper, previous year question, and all the test series curated by the top educator. You can access all type of test series out here. You will all, this is also including the grand test for the NEET PG, INSCT, FMG. So this is very beneficial for all of those who are looking for only the test series. You can join this Unacademy Lite for the NEET PG. Moving further, this is the batch we are going to start, which is 3-month fee is a 5,500, but the pre-launch price is 4,950 only. 6-month fee is 10,000, but the pre-launch price is 9,000 only. 1-year fee is 12,000, but the pre-launch price is 10,800 only. So you have to use the code to get additional 10% off. You have to use the code, that is it, Dr. Nidhi. By using this code, your fees will be reduced by 10%. So that will become more economical for all of you. Coming to this auto daily practice paper, we are launched with this one. In this, what happened, you are getting 5 to 10 MCQ after every live classes. This question are handpicked by your educator, and that is related to the topic covered in the session only. So that is going to help you to enhance your concept. So that is very beneficial. We are launched with this for the live classes students. So we are also started with this doubt clarification batch from the 6th April. All the subject-wise doubt can be cleared in this doubt clarification batch. This is for the upcoming examination, that is INICT NEET PG May 2022 and the FMG June 2022. So those who are targeting these exams, you can join this doubt clarification batch and clear doubts regarding any topic. Moving further, they are our FMG December 2021 toppers. So Next is the special class feature. Our special class is also free of cost, but they are way more special from YouTube session. How they are special? Because all the classes are live classes. Live classes are interactive session. You can interact with your educator and clear your doubt in live session. Post feature are there. From that you can better understand your topic. Raise a hand feature is there. Now you can talk to your educator in the live classes and clear your doubt in live session only. If you follow an educator, you will get notification of any upcoming courses or any upcoming special classes. After the lecture, you can download the PDF and revise it anytime, anywhere. So if you hadn't yet downloaded this Unacademy learning app, do download this app and use the invite code that is Dr. Nidhi. By using this code, all the free classes of yours will be open. Good morning, Dr. Rohit. Moving further, we are starting this NEET PG 2022 All Educator Revision Batch. This is already started. So anybody who are targeting this NEET PG 2022, you can revise your topic by joining this NEET PG 2022 revision batches. Moving further, we are started with this MBBS first year foundation batch. So those who are in first prof, they can join this one. And this all the first year subject will be covered. And in this, there will be the practical and Viva guidance session will be there. Answer writing guidance session will be there. 120 hours will be dedicated for each and every subject. Subject wise test will be there. Live interactive sessions will be there with the top educator. We will have the doubt clarification session also. We will have a feature that is the raise a hand feature. From that you can clear your doubt in the live session. Good morning, Dr. Shivani. Good morning, Dr. New. Moving further, this is the fee structure for the plus subscription. This is the fee structure for the iconic subscription. And this is the fee structure for the light subscription where you can access all the NEET PG test series. Moving further to our topic, today we are going to study about the body fluids. So first coming to the introduction part, our body weight is majorly contributed by this body water. So there is a concept which is known as the total body water. Why there is a concept of this total body water? Because our weight is majorly contributed by our water content. Good morning, Dr. Shoham. So now coming to the determinants for the total body factor. There are particularly two major determinants for the total body factor. First is the sex and second is the age. First coming to the sex. In male, the total body water is 60% of body weight is the water in the male. So total body water in male is 60% of body weight, and for healthy individual it is about 42 liter of water. In female, the total body water is 50% of body weight as water in female. So why the total body water in female is less? Because the total body water is inversely proportional to the fat content. Water content in our body is inversely proportional to the fat content. And in female, the fat content is more. That's why the total body water in female is less. So that's why the total body water in female is 50% of body weight, while in male it is 60% of body weight. Is this clear? Everybody, is this clear? Do reply fast. Moving to the next factor, that is age. Children's, when we are talking about the children, total body water is 75% of body weight. Means total body water in the children's are more than adults, and that's why children are more prone to dehydration, because the water content is more in children in normal situation. So that's why children are more prone to dehydration. So the two major factors are sex and the age. That is the major factor that contribute this total body water. Now coming to its distribution. Total body water is 60% of body weight is our water. And this can be either in the form of intracellular fluid or the extracellular fluid. This now coming to the intracellular fluid, it is contributing 40% of body weight. So this intracellular fluid is 2/3 of total body water. So next, the extracellular fluid, that is 20% of body weight, means it is covering 1/3 of the total body water. Means our total body water is 2/3 contributed by the ICF and 1/3 it is contributed by ECF. Now ECF can be either in the form of interstitial fluid or the plasma. What do you mean by this interstitial fluid and the plasma? Interstitial fluid is the fluid that is present between the two cells. So this is the interstitial fluid. Interstitial fluid basically contributes 15% of body weight. So that is about 3/4 of the extracellular fluid. So 3/4 of the ECF is contributed by this interstitial fluid. Now coming to the plasma. What is the plasma? When we remove the blood corpuscles from the blood, the remaining component is plasma. So this plasma is contributing 5% of a body weight. Means 1/4 of the ECF is contributed by this plasma. Is this clear? So this distribution is very important from the exam point of view. Do remember everybody. Is this clear with everyone? Do reply fast. Shall we proceed further? So let me revise this one. Total body water is 16% of body weight is our water. Intracellular fluid is contributing 40% of body weight. ECF is contributing 20% of body weight. Means ICF is contributing 2/3 of total body water. ECF is contributing 1/3 of total body water. This ECF can be either in the form of interstitial fluid or the plasma. Interstitial fluid is 3/4 of the ECF, while plasma is 1/4 of the ECF. So moving further, this formula is important. Total blood volume is equal to 8% of a body weight. Means blood volume is 8% of our body weight is our blood. And this blood contains plasma as well as blood corpuscles. And we already discussed 5% is our plasma. So rest 3% is our blood corpuscles. So this formula is important. Next is the total blood volume is equal to plasma volume upon 1 minus hematocrit. So this formula is also very important. Do remember everyone. So these two formula are important. From these two formula we can calculate the total blood volume. So moving further to the measurement. How this is measured? How the body fluid of different compartment is measured. This is measured by the Stewart-Hamilton method, which is also known as indicator dilution method. Means out here certain indicators are used and they are diluted, and from that we measure this body fluid of each and every compartment. So first, coming to the criteria for selecting the dye. The dye should evenly distribute in the compartment and it should not leave the compartment. If these two criteria are fulfilled, then only this dye is used as an indicator to measure the body fluid. So what are other two criteria? Dye should be evenly distributed in the compartment and it should not leave the compartment. The important formula out here is how we calculate the volume of body fluid in each and every compartment is equal to amount of a dye injected upon concentration of a dye. This gives the volume. So the basic formula we all know, volume is equal to amount upon a concentration. So do remember this formula. From this we can remember this formula. That is the volume of any body fluid is equal to amount of a dye injected upon a concentration of a dye. So this formula is important. Do remember. Now coming to the indicators. So for measuring the total body water, the indicator used are deuterium oxide and the tritium oxide. Now coming to the ECF. To measure the ECF, indicator used are inulin, sucrose, mannitol, sodium thiosulfate. Moving to the plasma, to measure the plasma, the dye used is radio-labeled albumin, Evans blue dye. For measuring the blood volume, we use this chromium nitrate, the RBC. So this chart is very important. Do remember everybody. So to measure the different compartment volume, different indicators are used. For total body water, we are using the deuterium oxide and tritium oxide. To measure the ACF, we are using inulin, sucrose, mannitol, sodium thiosulfate. To measure the plasma, we use this radio-labeled albumin and Evans blue dye. To measure the blood volume, we use this chromium tagged RBC. So what we all are seeing in this chart, we are not getting the indicator for intracellular fluid and interstitial fluid. So these cannot be measured via using indicator because there are no indicator to measure this volume, that is intracellular volume and interstitial volume. So they are basically measured by the indirect technique. So what is the direct measurement? What is indirect measurement? First, coming to this direct measurement, those substance which has indicator can be measured by this technique, and we have indicator for total body water, ECF, plasma volume and the blood volume. So all these four volume can be calculated by this direct measurement. Coming to the indirect measurement, for indirect measurement there is no indicators available such as our interstitial fluid and the intracellular fluid. So no indicators are available for these two. So they are measured via the indirect measurement. For indirect measurement, the formulas are, we all know total body water is in the form of ECF and ICF, and from this we can calculate ICF is equal to total body water minus ECF, and ECF is in the form of plasma volume and interstitial volume. So we can calculate this interstitial volume from this formula. So this is the indirect measurement. Is this clear with everybody? Do reply fast. Is this clear? So indirect measurement is done for the volume whose indicator is not available. Do reply fast. Is this clear? Okay, fine. Moving further. This is also important. The major cation in the ECF is the sodium cation, and major anion in the ECF is chloride anion, and the pH of ECF is 7.4. When we are talking about intracellular fluid, the major cation is potassium, and after the potassium we have a manganese. And when we are talking about anion in the ICF, it is the phosphate and the protein. Protein also act like an anion. They are non-diffusible anion in the intracellular compartment. Do remember, everybody. Now coming to the pH of ICF. The ICF pH is 7. So this chart is very important. The major cation in the ECF is sodium. Major anion is in the ECF is chloride. Major cation in the ICF is the potassium, and major anion in the ICF is the phosphate anion. So moving further to the Darrow unit. This is very, very important. From this Darrow unit, we can differentiate different type of disturbance like overhydration or the dehydration. What is this Darrow unit? So what happened? Volume of fluid and osmolarity is plotted in the form of graph, and both intracellular compartment as well as extracellular compartment volume and osmolarity is plotted in the form of graph, and that is known as the Darrow unit. In this Darrow unit, what happened? Let me draw this one. On x-axis we take the volume, on a y-axis we take the osmolarity. So on x-axis we are taking this volume, on y-axis we are taking the osmolarity. So first let me draw this Darrow unit for normal curve. So this is the Darrow unit in the normal situation. So this is our intracellular fluid compartment. This is our extracellular fluid compartment. Intracellular fluid compartment is contributing 2/3 of total body water. In extracellular fluid compartment is contributing 1/3 of total body water. So this is, and under the normal situation, the osmolality of both the compartment are equal. So this is our normal Darrow unit. Is this clear with everybody? So we will draw this Darrow unit in different disturbance like overhydration and dehydration. Is this clear? Shall we proceed to the disturbance, everybody? So let me see this one. This is the intracellular fluid compartment. This is the extracellular fluid compartment. Intracellular fluid compartment is contributing the 2/3 of the total body water. And ECF is contributing 1/3 of total body water. So in a normal healthy individual, it is 14 liter and it is 28 liter. So these all data are important. Do remember, everybody. So moving further to this Darrow unit in different disturbance like overhydration and the dehydration. So first taking to the situation of dehydration. In this different type of dehydration is there. First is isotonic dehydration. What do you mean by this isotonic dehydration? Means after the dehydration, the tonicity of ECF remains same. Anything which is occurring, either it is a dehydration or overhydration, it will be occurring firstly in the ECF, then later on the changes will be there in the ECF intracellular fluid also, but the first change is going to happen in the ECF only. So what do you mean by this isotonic dehydration? Means after the dehydration, the first thing what is happening is the tonicity of ECF remains same. So what happened in isotonic dehydration? Both sodium and water loss occur in equal proportion, and when both is lost in equal proportion, let me draw this for all of you. First, let me draw the normal Darrow unit. So this is the normal Darrow unit. So this is our intracellular fluid compartment. This is our extracellular fluid compartment. And the situation is our isotonic dehydration, means both solute and water loss occur in equal proportion. So after the dehydration, the tonicity of this chamber remains same. It remain isotonic. So only and only what happened, the tonicity remains same, only and only ECF volume decreases. So only and only ECF volume decreases, but its osmolarity is going to remain same because it is a type of isotonic dehydration. So what changes we will see in this Darrow unit? The ECF volume decreases. So only and only what changes we will see? This ECF volume decreases, ECF osmolarity remains same. Since osmolarity remains same, there will be no water shift. So this is the shifted Darrow unit in this situation. This is the shifted Darrow unit. So this isotonic dehydration occur in the cases of GI fluid loss, in the cases of burns, and in the cases of hemorrhage. Do you remember, everybody? Is this clear with everybody? The isotonic dehydration, see what happened due to dehydration? ECF volume is going to decrease since the dehydration is isotonic dehydration. So the tonicity remains same. So the osmolarity is going to remain same. Only and only ECF volume decreases. Is this clear with everybody? So this is the shifted Darrow unit in this situation. To reply fast, is this clear with everybody? Coming to the next one, that is a hypertonic dehydration. Means after the dehydration, the tonicity of ECF is going to increase, or you can say there is a loss of hypotonic fluid from the ECF. Okay, let me draw this one for all of you. So this is our normal Darrow unit first. In the red color, this is our normal Darrow unit. This is intracellular fluid compartment, which is contributing 2/3 of total body water. This is extracellular fluid compartment, which is contributing 1/3 of total body water. And the situation is hypertonic dehydration. Means there is a loss of hypotonic fluid. So out here what happened? The water loss, solute loss is less, but the water loss is more out here. So this is a hypertonic dehydration. Means after the dehydration, what happened? The tonicity of, let me change the color for all of you. We are drawing the shifting of this Darrow unit in the blue color. So after the dehydration, obviously ECF volume is going to decrease, but due to the hypertonic dehydration, ECF osmolarity also increases. So what is the situation now? This is the hypertonic chamber. Comparatively, the ICF become hypotonic out here. So water shift will be there, and we all know water shift from lower concentration of solution to the higher concentration of the solution. So there will be shift of water from ICF to ECF. Is this clear with everybody? So this water shift is from the ICF to the ECF. So what happened? There will be the secondary change in the ICF. What happened to the ICF volume? Obviously, ICF volume will decrease. Is this clear with everybody? The ICF volume is decreased. And since water is moving from ICF to ECF, ICF osmolarity is going to increase, and it increases until the new equilibrium is achieved. So see, this is the shifted Darrow unit in hypertonic dehydration. Is this clear with everyone? So hypertonic dehydration, what all we see? First change, there will be decrease in ECF volume. ECF osmolarity is going to increase, and there will be secondary change in the ICF. ICF volume decreases, ICF osmolarity is going to increase until the new equilibrium is achieved. Same thing is written out here. Hypertonic dehydration means water loss from the ECF is more. So the ECF tonicity is going to increase, and since there is hypertonic concentration of ECF, water is moving from the ICF to the ECF, so there will be second dehydration. Is this clear with everyone? How this Darrow unit shift in hypertonic dehydration? Is this clear? Everybody, do reply fast. Okay, fine. Moving further. See, this is the shifted Darrow unit. ECF volume decreases, ECF osmolarity increases. That's why there is a water shift. So due to water shift, secondarily ICF volume decreases, ICF osmolarity increases until the new equilibrium is achieved. Coming to the next one, that is a hypotonic dehydration. Means after the dehydration, tonicity of ECF is going to decrease. So let me draw this one for all of you. This is the normal Darrow unit. This is intracellular fluid compartment. This is extracellular fluid compartment. So what is the situation? Dehydration is there. So ECF volume is going to decrease. Hypotonic dehydration means after the dehydration, tonicity of ECF is going to decrease. Or you can say there is a loss of hypertonic fluid from the ECF. So out here what happens? The solute loss is more. So due to that, there will be the shifting of this Darrow unit. So ECF volume is going to decrease. ECF, yeah, way true, Dr. Kartika. So ECF volume is going to decrease. ECF osmolarity is going to decrease. So this is the situation. This ECF become comparatively hypotonic. So this ICF become comparatively hypertonic. So there will be the water shift, and the direction of water shift in this situation is, anyone? The direction of water shift in this situation will be, do reply fast everybody. The direction of water shift in this will be, water will shift from the ECF to the ICF, from lower concentration of solution to the higher concentration of solution. Yeah, very true. From the ECF it will go to the ICF. So there will be the secondarily change in the ICF. ICF volume is going to increase. ICF osmolarity is going to decrease until the new equilibrium is achieved. So this is the shifted Darrow unit in the hypotonic dehydration. Same thing is written out here. Solute loss out here is more. ECF will become hypotonic. So there will be water shift from the ECF to ICF. So ICF volume is secondarily increased. And this is seen under the situation of primary hypoadrenal. Primary hypoadrenalocorticism. In both the situation, aldosterone is less, and since aldosterone is less, there is less sodium reabsorption, or you can say more loss of this sodium will be there, and that is going to cause this hypotonic dehydration. Is this clear with everybody? So all the dehydration are covered in this one. Now coming to the overhydration. This is the shifted Darrow unit and hypotonic dehydration. ECF volume decreases, ECF osmolarity decreases, so there is the water shift, and due to water shift, ICF volume increases, ICF osmolarity decreases until the new equilibrium is achieved. So moving further to the next one, that is overhydration. We will draw the Darrow unit in the situation of this overhydration. Three type of overhydration is there: isotonic overhydration, hypertonic overhydration, or hypotonic overhydration. Was coming to this isotonic overhydration. So overhydration is there, means ECF volume is going to increase obviously. So this is our normal Darrow unit. This is intracellular fluid compartment. This is extracellular fluid compartment. Isotonic hydration means after the hydration, the tonicity of ECF is going to remain same. So what happened in this one? Let me draw this shift. So ECF osmolarity remains same because of isotonic term, and the hydration is there. So ECF volume is going to increase. So since there is no change in osmolarity, so there will be no water shift in this situation. So the ICF osmolarity, ICF, this is the shifted dynamic. Only and only one change we will see, that is ECF volume is going to increase in this situation. Okay, fine. This is seen when we administer oral or IV isotonic saline. So it is going to cause this isotonic hydration. Is this clear with everybody? Do reply fast. Shall we proceed further? Okay, fine. Moving to the next situation. That is the hypertonic hydration. Means after the hydration, tonicity of ECF is going to increase. So let me draw this one for all of you. This is our normal Darwinate first of all. Yeah, this is our normal Darwinate. This is intracellular fluid compartment. This is extracellular fluid compartment. Intracellular fluid compartment is contributing 2/3 of total body water, and ECF is contributing 1/3 of total body water. So now situation is hydration is there, and it is going to cause this hypertonic nature. So what will be the shift? ECF volume is going to increase, ECF osmolarity is going to increase. So let me change the color for all of you. This is the new Darwinate for the ECF. ECF osmolarity increases, ECF volume increases. So what happened due to that? This ECF become hypertonic. So the comparatively our ICF is going to cause this hypotonic. So there will be the water shift, and water shift will be from the lower concentration of solution to higher concentration of the solution. So that is from the ICF to the ECF. So what happened? The ICF volume is going to decrease because the water is shifting from ICF. So ICF osmolarity is also going to increase until the new equilibrium is achieved. So this is the shifted Darwinate in this situation. What all are the changes? The ECF volume increases, ECF osmolarity increases. That's why there is a water shift from the ICF to the ECF. So the ICF volume decreases, secondarily ICF osmolarity increases until the new equilibrium is achieved. And this is seen when we administer oral or IV hypertonic saline. Is this clear with everybody? So we are left with only one situation, that is the hypotonic hydration. Everyone, is this clear? Shall we proceed further? Okay, fine. Moving to the next situation, that is the hypotonic overhydration. So let me draw the curve for all of you. This is our normal Darwinate first of all. This is intracellular fluid compartment, which is contributing 2/3. This is extracellular fluid compartment, which is contributing 1/3. So what happened? The overhydration is there, and that is causing this hypotonic nature of ECF. So ECF osmolarity is going to decrease, and ECF volume is going to increase in this situation. So what happened? The tonicity of this ECF is decreased. So comparatively our ICF become hypotonic. So there will be the water shift, and water shift will be from lower concentration of solution to the higher concentration of solution. So it will shift from the ECF to the ICF. So what happened to the ICF volume? ICF volume is going to increase in this situation. ICF osmolarity is going to decrease because water is added in this compartment. So ICF osmolarity is going to decrease in this situation until the new equilibrium is achieved. So this is the new Darrow unit. This what all changes we are seeing. This ECF volume is, so ECF volume in this situation is increased, ECF osmolarity is decreased, and there is secondary change. ICF volume increases, ICF osmolarity decreases until the new equilibrium is achieved. So this is the shifted Darrow unit in overhydration and dehydration. From the Darrow unit, we can differentiate which type of hydration is there or which type of overhydration is there, which type of dehydration is there. Is this clear? All the concept regarding the Darrow unit, is this clear with everybody? If anybody has any doubt, you can clear it out. If anybody has any doubt regarding this body fluid, you can ask in the session. This is the all concept. This concept is going to help you to ace your professional examination also and NEET PG, upcoming NEET PG for all of you also. So let me take you to some interesting questions. First, radio-labeled albumin is used for measurement of plasma volume, interstitial fluid volume, ICF or the ECF. So everybody answer this question. Radio-labeled albumin is used for measurement of everybody answer this question. Yeah, very true. It is the plasma volume. Radio-labeled albumin is used to measure the plasma volume. Coming to the next question. This is the question based on the formula which we studied. A man weight is given. His hematocrit is given, that is 45%. What will be his plasma volume? So everybody answer this question. What is the formula? Anybody? What was the formula we studied in today's session to calculate this plasma volume? What was the formula, anybody? The formula was blood volume is equal to 8% of body weight, remember? Yeah, very true, Dr. Rita. Answer is A. Very good. 8% of this 60 kg. So that is going to be equal to 4.8 liter. So this blood volume is 4.8 liter. And the next formula for blood volume is equal to plasma volume upon 1 minus hematocrit. Remember, everyone? So this plasma volume is equal to blood volume, that is 4.8 liter, into 1 minus hematocrit. Hematocrit is 45%. So 1 minus 0.05 is equal to 0.55. So answer will be 2640 liter. Is this clear with everybody? So answer is A. Do reply fast. Is this clear with everyone? Okay, fine. Moving to the next question. This is also same type of question. So skipping this one, coming to the next one. Total body water is 40% of body weight, 20% of body weight, 10% of body weight, or 60% of body weight. Total body water is. Everybody answer this question. Total body water is. Yeah, very true. I guess this is the easy one. That is, it is equal to 60% of a body weight. Very true. Coming to the next one, volume of ICF in the body is 0.2 into body weight, 0.4 into body weight, 0.6 into body weight, or 0.8 into body weight. ICF in the body is, volume of ICF in the body is. So everybody answered this question. Everybody answer this question. Yeah, ICF is contributing 40% of a body weight and ECF is contributing 20% of body weight. So answer is B. These are some important questions. ECF is how many part of total body water? 1/3, half, 2/3 or none? Everybody answer this question. ECF is how many part of total body water? Everybody answer this question. ECF is how much part of total body water? Yeah, very true. Answer is 1/3. ECF is 20% contributing to our total body weight. ICF is contributing 40%. So it is 2/3. Our ICF is contributing 2/3 and ECF is contributing 1/3 of the total body water. So answer is A. So these are some important questions you will get in the next examination also. You can answer all the questions from your that professional examination from this topic. So you will definitely be benefited from all these sessions. Let me take you to one more question from this one. From the Darrow unit. The effect of infusion of hypotonic saline is option A, increase in ICF only. Option B, increase in ECF only. Option C, increase in both ICF and ECF. Option D, increase in ICF and decrease in ECF. So everybody answer this question. Effect of infusion of hypotonic saline is everybody answer this question. Effect of infusion of hypotonic saline is so what happened due to it is asking about the volume. Dr. Kartika, it is asking about the volume change in this one. Question is asking about the volume. Do reply fast. The effect of infusion of hypotonic saline on the volume is see what happened due to infusion. ECF volume is going to increase in this situation, and since what happened, see what happened out here. This is the normal Darrow unit. When we infuse the hypotonic saline, let me change this one, the hypotonic saline. So the ECF osmolarity is going to decrease, ECF volume is going to increase. Since its osmolarity decreases, there will be the water shift from lower concentration to higher concentration. So what happened is intracellular fluid volume secondarily changes, its osmolarity secondarily decreases until the new equilibrium is achieved. So what happened in this situation? Volume of ICF increases, volume of ECF also increases. So answer is C, increase in both ICF and ECF volume. Dr. Kardika, see what happened? Due to the osmolarity is decreasing, this chamber become hypotonic, this chamber become hypertonic, and the osmosis always occur from lower concentration of solution to the higher concentration of solution. So water will shift from the ECF to the ICF, not from the ICF. Yeah, water will move into the ECF. So the ECF volume increases due to addition, and secondarily there is increase in this ICF volume. So we can say there is increase in both ICF and ECF. Is this clear? Everyone, is this clear? Okay, fine. These are some important questions you will get in your professional examination plus next examination. So hope you all like this session. If anybody has any doubt regarding today's body fluid session, you can ask in the session. Hope you all like this session, everybody. If you like this session, do share. That is important. Do share. By sharing, the class become more interactive. So do share, everybody. Study hard. You will definitely able to achieve your target. You will definitely crack your professional examination with good marks. You will definitely crack your next examination also. So study hard, you will definitely able to achieve your each and every target. There is no shortcut for any examination or anything. So do hard work, you will definitely be succeeded in your examination. This is the code Dr. Nidhi. If you like the session, you can join the detailed session of the Force Prof series also. We are started with that. You can join that and you can get your good marks in your professional examination also. We will have the answer writing session in that also. So this is the code Dr. Nidhi. If you want to join that, use this code Dr. Nidhi to get additional 10% off. Most welcome, everybody. So that's all for today. Thank you so much for joining. See you all in the next session. The timing will be same. Thank you so much, everyone. The timing will be same. We will have the session tomorrow at the same timing, that is at 11 p.m. We will have the session at 11 a.m. tomorrow also. So stay tuned to everybody. Thank you so much. Bye-bye, everyone.